Okay, welcome back. This is Unit 1, Lesson 4, Control Flow. So we're going to learn how to use conditional statements. An example of a program that uses conditional statement is when you try to enter an application that requires a password, it has to compare that password to the safe password to make sure is equal to it, and then it will let you enter your application. These are the logical operators that we'll be using. These are the same logical operators that are used in C++ and Java. And we start with the comparing. So one equal sign means to assign. So you can't use that to compare two things, like is the password equal to Joe? You have to use two equal signs. So two equal signs means to compare. The exclamation point with the equal sign to the right means not equal to. So the exclamation point means not equal to. Greater than, equal to. So this would be like, is the number greater than or equal to 0? So it includes 0. Less than does not include the number, like is the number less than 0? It would be all negative numbers, does not include 0. Less than or equal to, and operator, like is the number greater than 0 and less than or equal to 10. So I want all numbers between 1 and 10. I would use the AND operator. And then we have OR. For example, if I'm asking the user to enter the character M, for example, and I don't care if it's capital or lowercase, I could say, is the character entered equal to uppercase M or lowercase m? So this is OR. These are two bars going up and down. This is found above the backslash on your keyboard. And then this is the not operator, which we use up here with not equal to. You can do the you can use the not operator, for example, like not, and then inside you have some condition that returns true or false. So it'd be the opposite of whatever it gives you inside the condition. And we'll look at more of that later. That might be confusing at this time if you're not used to using these. These are our logical operators. This is the if statement. This is how we check. These are called conditional statements. And in Swift and C++ and Java, I keep talking about those three languages just because Swift comes from Object-C, and it just has all these flavoring of Java, and you'll be so happy when you take 1437 and COSE 1437 and you're studying Java and you notice that it's the same things. So here we have the condition, and the condition is going to be something that's going to give you a true or false. So it's an equal to, not equal to, etc. Then you have what's called a curly brace. This is an open curly brace. Then we put the code here. What do we want to happen if this is true or false? And then we have the close curly brace. So for example, if temperature is greater than or equal to 100, then we're going to print the water is boiling. Okay. If else statement. If condition is true, do this, else do this. Or if condition is false, do this, else do this. Example, if the temperature is greater than or equal to 100, we're going to print water is boiling, else we're going to print water is not boiling. Notice you have open curly brace, close curly brace, then the else, open curly brace, close curly brace. These curly braces can get you in trouble if you don't have the matching curly braces. As you type an if statement in, automatically it puts the braces in there for you, so don't delete them. Okay, Boolean values. Boolean values are values that are true and false values. So right here we have number 1000. This is an integer. Number greater than 10. This is going to return a true or false. So the data type assigned to is small number. Is small number, the data type to this constant is going to be Boolean. Here we have let speed limit equals 65, let current speed equals 72, let is speeding equals, so if current speed is greater than speed limit, which it is, then is speeding would be true. Does that make sense? This is greater than that. That gives us a true, and this gets assigned a true. Okay, is snowing equals false. So do we want to know if it's snowing or not? This is saying if is snowing, then print. So remember, is snowing is false. So if it's snowing, then we're going to print it is not snowing. Boolean value and let temperature equal 70, let temperature greater than or equal to 65, and temperature less than or equal to 75. So if we have a temperature between 65 and 75, including 65 and 75, then we're going to print the temperature is just right. Else, we're going to compare it to 65. If it's less than 65, we're going to print it's too cold. Else, we're going to print it is too hot. So here, our temperature has been set to 70. So it's going to be right here. It's going to fall between 65 and 75. So it's going to print this statement. It's never going to go check here, and it's never going to go check here. Once it finds a true statement, it exits the conditional statement. Okay, here's an OR. We've set our first variable to false. Our second variable has been set to true. And we say, if it is plugged in or has battery power, print you can use your laptop. Else it prints this little character. So is plugged in equal to true? Well, let's see. Plugged in is equal to false. And then has battery power is equal to true. So a false or a true is going to give you a true. So it's going to print you can use your laptop. With an or statement, only one of the conditions has to be true for the statement to be true. With an and, both conditions have to be true. Okay? Here's a switch statement. Switch statements we use for example, like let's say that you enter a grade, right? And we know that typically anything between 90 or let's see here. Say you enter a letter grade, and you enter the letter grade A, B, C, D, F. You know that typically anything between 90 and 100 is going to be an A. 89 to 80 is going to be a B. So if somebody enters the letter A, I can print out 90 to 100, those words. So the value that I'm checking, it's going to be a value where I'm going to compare to one thing, like is it equal to A or equal to B or equal to C? Usually we don't say like is it between 1 and 10. We're usually looking for things that are equal. So the keywords used in a switch statement is the word switch and case. And then we have something at default. So if it's not this and it's not this and it's not this, then it goes down to the default statement. Let's just take a look at an example. So here we have a constant, and that constant has been assigned a number 2. We're going to switch on the constant, and we're going to say, okay, is this constant a 1? No. Is this constant a 2? Yes, it's equal to 2. Number of wheels is equal to 2. So it's going to do this. It's going to print bicycle, and it's going to go out here and exit. It's not going to do anything else. Now, if I had put a 5 here, if I made wheels a 5, it would check to see if it's a 1, that would be false, a 2 would be false, a 3 would be false, 4 would be false. You would go to the default and say, that is a lot of wheels. Okay? So we're just looking to see if something is equal to each one of these. Switch statement with multiple conditions. Sometimes we want to print the same thing for multiple, like here, multiple letters, like A, E, I, O, U. Those are all vowels. So instead of doing case A, that's a vowel, case E is a vowel, you can put each one separated by commas, and it will check to see if character is equal to A or E or I or U, O or U. So if there's like an or here. If it's not equal to any of those, then it prints not a vowel. And then ranges. So we don't typically use a case statement for ranges, but you can. I'd rather use if statements. So here you have distance. Case 0 to 9, your distance is close. 10 to 99, your destination is a medium distance. 100 to 999, you're far from here. And then it says, are you sure you want to travel this far? If it's something greater than 1,000. So this is 0 to 9, including 0 and 9. So it's given us a little exercise here. It says, rewrite the following using a switch statement. So I'm just going to give you a few minutes to think about how would you rewrite this using a switch statement. So you would switch on what variable? You would switch on temperature. And your first case would be what? You could start with let's take a look and see how they did it. Oops. Okay, so they said int min. Oh, I see how they did. So you can use this here called int min. It says hint the smallest possible value for an integer is int.min. So automatically temperature, it's an integer. You don't know what temperature they're going to enter. They could enter -10. So since you don't know what range is going to be, then you could just use int min, which is the least, the smallest integer possible that someone could enter. And so we first compare to see if it's between that's whatever the smallest integer is, all the way to 64, and then 65 to 75, and between those, and then else it's too hot. Now, something else you can do is typically, right? Well, what you want to do is you want to go and look to see what is the smallest or the coldest temperature ever recorded. And you could put, okay, is it between, let's just say you put negative, I don't know, you could do some extreme number like -100. Don't think we've ever recorded that temperature, but let's just say -100 to 64. So you could put something here that you know that nobody's going to reach. Okay? Right, so we're going to look at lab control flow in lesson 4. Do we have unit 1? So that's unit 2. Control flow. Okay. So for this particular one, it says for each of the logical expressions below, print out what you think the resulting value will be. I'm very sorry that I'm coughing. Just got started to feel sick yesterday. So here it says, print out what you think the resulting value will be, true or false. Then print out the actual expression to see if you are right. So here's what it wants us to do. So first, I'm going to say, okay, is this true or false? So it's 9 equal to 9. Of course, I know that that's true, but then it wants me to, I'm just going to do this. Print 9 equals 9. I'm not going to do all this, guys, okay? That's just way too much work. So I'm looking at it. In my head, I'm going to say, yeah, that is true. Okay, and then I'm just going to press, oh, well, I'm not going to press enter because it already told me right here it's true. I trust that you can do this part in your head. You don't have to type all that in. It's just a waste of time. Okay, and this one says 9 is not equal to 9. Well, 9 is equal to 9, so this would be false. And then I'm just going to see if I am right or not. Nine not equal to 9. And it gives me false, and I was right. Okay, it's 47 greater than 90. That would be true. I mean false. 47 is not greater than 90. Okay, now just go and do all those. And then you can check to see if you're right or not. Here's an example of an and. So if you have an and, this has to be true, and this has to be true for the whole statement to be true. So is 47 greater than 90? This is false. Once I know this is false, I don't even need to, the compiler doesn't even look at this. This is an and. It doesn't even have to check if this is true or not. Automatically, if this is false and it's an and, you know it's going to be false. This one, it's an OR. So if this is false, it's going to check here because it's an OR. If this is true, it stops and it gives you a true. So it's 47 greater than 90, that's false. So I have to go check this. 47 is less than 90, that's true. So this condition is going to output a true. False or true. Like, is my name Jeanette or Marcy? My name is Jeanette. One of them has to be true. But I can't say is my name Jeanette and Marcy. Well, I guess if I had a first name and middle name, I could do that. But I can't say, like, am I 40 years old and 50 years old. I can't be two ages at once. Okay, and this one says not true. Opposite of true is false, so this is a false statement. Let's look at something a little bit more complex. Okay, so in this one you want your fitness tracking app to give as much encouragement as possible to your users. You're going to create a variable, steps equal to the number of steps you guess you've taken today. Create a constant called step goal equal to 10,000. So I have a variable called steps. I'll assign it something in a minute. I have a constant called step goal. And that one tells me I got to assign it 10,000. So 10, 1, 2, 3. And remember, I can put a little line there. If I want to make it more obvious that it's 10,000. Where my comma goes, I put a little line. And then I'm going to guess that I took 1,000 steps. Okay? And then it says write an if-else statement that will print you're almost halfway there if the steps is less than half of the step goal, and we'll print you're over halfway there if the step is greater than half. Okay, so if my steps, okay, so my steps is 1,000. I'm going to compare it to step goal. So if the steps is, doesn't matter which one you start with. I'm going to start with greater than or equal to less than half of the step goal. Yeah, greater than or equal to step goal divided by 2. So step goal is 10,000. If this is 5,000, if my steps is greater than or equal to 5,000, I'm going to print what am I going to print? You're almost half, no, yeah, no, you're over halfway there. You are over halfway there. Okay. Else. Notice when I type in my open curly brace, it automatically puts my close curly brace. You're almost halfway. And I forgot one. Okay. So I have 1,000. So 1,000 is not greater than or equal to 5,000. So it prints this statement here. Now let me show you what happens here if I take that out. If I take my curly braces out. So if I don't put my curly braces, it says expected curly brace after the if condition. So it doesn't actually tell you that it needs the curly brace. It's just telling you something is wrong. So it gets really confused. Now in Java and C++, you can do it without the curly braces. So that's why I wanted to show you that, just in case you've taken the other languages before. It does require the curly braces, even if you just have one statement here. Okay, let's do one example with the switch statement. Here's a switch statement. So you decide that you want your fitness tracker to have a feature that helps users stay inside specified heart rate zones. You display a message to the user telling them to go a little faster to increase their heart rate if they are below the target. Create these constants. Okay, so I'm going to create constants. That would be let is in target, and that equal expressions that evaluate to where or not current HR is between the lower and upper bounds. Okay, just define each one. Let is above target. Okay, let's see what he wants us to assign to these variables, to these constants. You'll display a message to the user telling them to go a little faster to increase their heart rate if they are below the target. Spot on if they are in the target. And tell them to slow it down a little if they are over the target. Okay, so this is current heart rate. This is our lower bound and our upper bound. So we're going to create these that equal expressions that evaluate to whether or not current heart rate is between the lower and upper bounds. Okay, so if it's between the lower and upper bounds, we're doing okay. If we're above the upper bound, we're going too fast. If it's below the lower bound, we're going too slow. So 147 is just right, it's between both of those. Okay. But thought this was a switch. It says, then write an if-else statement that will print you're right on track. If they're inside the target zone, you're doing great. Okay. Okay, I thought this was a switch. It's a switch statement. Okay, let's take a look at the next one, because that's not a switch statement. So we'll do this one real quick. So this one is saying if our current heart rate there's two ways you can do this. So if the current heart rate is greater than target upper bound. So if it's greater than 150, then we can print too fast. So we can do it this way. Right now, current heart rate is not greater than 147, so it's not going to print anything. Else, if our current heart rate is less than target lower bound, we can say print too slow, else print just right. Okay, so we're at 147, so we would print just right. Now they were wanting you to define these variables here, so what they were wanting you to do, I mean, all I can think about it is if, I'm not sure why you would create these right here, these constants. Okay, I mean, the only thing I think of is if you say is var is in target, and you would put just right. So maybe this is what they want. And then here, you would just put is in target. Okay, so maybe they want the strings to be constants. You can do it either way. Okay. All right, that's the end of this lesson. Good luck with the lab, and please email me if you have any questions.